I already discussed first topic of set theory, that is set. In set, I discussed introduction to set, then how to represent set like set builder method and roster method. Then intervals in set like open interval and closed interval, set equality, empty set, Venn diagram, subset, size of set and power set. Next I will discuss set operation. First set operation is union. Definition 1, let A and B be two sets. The union of set A and B denoted by this A union B is this set that contains those elements that are either in A or in B or in both. A union B equals to X, X belongs to A or X belongs to B. Let's see one example. Example 1. Let first set contain 1, 3, 5. Second set contain 1, 2, 3. So it will contain 1, 3, 5 and 1, 2, 3. You just mark this 1 is repeated, this 3 is repeated. So you can write 1, 2, 3, 5. Both are equal, as in set repetition doesn't matter. So 2, 1 is equivalent to 1, 1. For cardinality, we count distinct element in this set. So you can say here cardinality is 4. Next definition 2, it's about intersection. Let A and B be set. The intersection of set A and B denoted by A and B is this set containing those elements in both A and B. In case of union, either in A or in B or in both. But in case of intersection, it should be present in both A and B. So you can say A intersection B equals to X, X belongs to A and X belongs to B. Let's see one example. Example 2. Let A contain 1, 3, 5, B contain 1, 2, 3, then their intersection. Which element are present in both? 1 present? Yes. 2 present? No. 2 present only in second set. 3 present? Yes. 3 is present in both set. 5 present? No. So 1, 3 are present both sets. That's why intersection will contain 1 and 3. Next definition 3, two sets are called disjoint if their intersection is empty set. For example, let A contain 1, 3, 5, 7, 9, B contain 2, 4, 6, 8, 10. There are no common. Okay, their intersection is 5. So you can say A and B are disjoint. Now Venn diagram for union and intersection. This is for union. This shaded area are for A union B, while this shaded area is for A intersection B, which are common in both set A and B. Next, principle of inclusion and exclusion. Now A union B cardinality. Size of A union B, if we write A cardinality plus B cardinality. Let's take an example. Let A contain 1, 2, 3, B contain 2, 4, 6. Now A union B will contain 1, 2, 3, 4, 6. Now what is A cardinality? A cardinality is 3, B cardinality is 3. 3 plus 3 will be 6. But A union B contain 5 element. So here if you will mark A contain 2, B also contain 2. So this element we count for both A and B. That's why for finding A union B, we need to subtract A intersection B from A plus B. So we will subtract A intersection B. As we counted these two times for set A and for set B, so I will subtract A intersection B cardinality. Now it will be 3 plus 3 minus 1. It's 5. So you can say A union B cardinality equals to A cardinality plus B cardinality minus A intersection B cardinality. We need to subtract A intersection B cardinality as the intersection element, the common element are repeated in both A and B. Next set operation is difference. Definition 4, let A and B be two sets. The difference of A and B denoted by A minus B is the set containing those elements that are in A but not in B. The difference of A and B also called as complement of B with respect to A. So it can be represented by A slash B or A minus B. That equals to x belongs to A and x naught belongs to B. Let's see next example, example 4. Let A contain 1, 3, 5, B contain 1, 2, 3. Now A minus B. A minus B will be the element which are present in A and not present in B. So here 1, 3 both are present in B. Only element 5 that is not present in B. So you can say A minus B will be 5. The elements which are present in A and not present in B. X belongs to A and X not belongs to B. In Venn diagram, we can represent A minus B like this. The portion of A which are not in B. So A intersection B is not part of A minus B. Only the portion of A which are not in B, that will be A minus B. Next, definition 5, it's about complement. Let U be the universal set. The complement of set A denoted by A complement. Above A we can write one bar is the complement of A with respect to U. U is our universal set. So therefore the complement of set A we can write as U minus A or U difference A. So A complement equals to X, X belongs to U universal set and X not belongs to A. A minus B, that we can write as A intersection B complement. In Venn diagram, how will represent? Let this is our U universal set, this is our A, then these area which are outside A and inside U are A complement. Let's see one example of complement. Example 5. Let A equals to A, E, I, O, U and U is our all alphabet. Then A complement will be rest alphabet which are present in U and not in A. So A complement will be rest alphabet which are not A, E, I, O, U. In today's lecture, I discussed set operation like union, intersection, difference and complement. In next lecture, I will discuss set identity. If today's lecture is helpful for you, please like, share and subscribe. Thank you.